So when you're going about the design process, obviously they're very different. Where do you start? Where do you start with the whole thing?
So again, it depends on what you are designing. Our focus for today's talk is obviously weight, because uh, I have worked on vehicles which move, and the efficiency is then depend on how much weight you have to move. So anything that is mobile, you need to you have weight aspect woven into the whole system design. If that vehicle has to fly, then it is whole another level of weight optimization. As we can see in airline industries, it is absolutely critical to save weights on each and every component. So there is a weight audit on even nuts and bolts. So interestingly enough, I started working on bolts. So right after my MTech in IIT Bombay, I joined engines department, and the first project that I got was to develop design process for bolts that are used in the engine. And not to mention, my friends were mocking me. They were making fun of it, that, oh, you're a engineer from IIT and then you're working on bolts. So it seems like a very insignificant component, but as it turns out, the bolts in current IC engines are pretty high tech. So we turn them till they yield inside, and this was because we could save a lot of weight. So by optimizing the design of bolts, we could save some weight on the engines. That is why the design was so advanced for the engine head bolts. And basically, that is, you can understand the importance of weight saving, where even a ground vehicle which weighs at least a ton in most cases, we were striving to save a few hundred grams in bolts, because that's what engineers do, right? That's what you as a designer have a responsibility to build your system in a way that is more efficient to run. So there are, obviously, when it comes to designing, there are multiple aspects. And the one aspect that I worked on that time was design optimization. And there can be different goals for optimization. And my goal at that time for that project was weight, to see how can we save weight by optimizing the design of bolts.
Saving a few hundred grams seems like a very aggressive strategy for weight saving. How does it impact the overall vehicle? Like doing this weight saving exercises for obviously not just bolts, but I'm assuming for every component. How does this impact like
Yes,
an overall vehicle?
correct. It's a good question, because it may seem little excessive or over engineering, saving a few hundred grams on a diesel engine, which weighs a lot actually. But if you consider a car as a system, it has about 20,000 components, right? Uh, if you don't optimize weight, your car will end up quite heavier than your other competitors. That this is why, even though the small saving that you get in small components, it seems very small in the overall weight of the system, but it is important to do that optimization on each and every component, because when they add up, then it will create a bigger difference on the system level.
Are there any common strategies that you would employ to achieve this kind of weight saving or lightweighting or optimization?
Yes. So first strategy as a designer is weight optimization. The design optimization. So the problem is with that is, now, with, like, we have spent so many years designing these machines, right? And we have optimized their shape as much as we can, as much as we could so far. There is not much room into it. So unless you come up with smart materials, there are many types of small smart materials, and or you change the material itself. So if not composite, then you have to go with lightweight materials. And what then what needs to happen is you are going to re-engineer that component, right? Because once you change, the material will have different properties, and you will have to re-engineer the entire component again. But that is the only avenue that is available in most cases these days, because you are done with the shape optimization of that component after so many iterations of design, that now you can look into different materials to save weight. And one more point I want to add is that you can do that strategically. So you can identify components which are critical, and where you can save the most amount of weight, right? So there are many components in a system where they are over designed. They don't need that much strength or stiffness for the given function. And then you can replace those components, some material, with some lightweight materials. So you have to identify smartly which components you can replace with lightweight materials.